Okay. In this question, we start here at O, and the plane travels 350 kilometres at 225 degrees true. So you can see if you draw in the north at O there, which they've done for you, this angle, as you go clockwise from the north around to that line out there to P, which is the direction the plane travelled, they're telling you that's 225 degrees. And they said it travelled for 350 kilometres, so we'll write that in there on that line, to reach P, which is down here. It then changed direction, travelled due north, like directly north. So on this it's straight up the page, because that's the direction north's marked in at, for 500 kilometres. So I'm going to write 500 there. That whole distance down from there to there is 500 kilometres. Okay, the first question they ask is, what is the distance from P to M? So we need to peel off a triangle here. We've got O, M, P that we're going to work with, and we have to find this distance that I'm colouring in blue here, the distance from P to M. Now, what information have they given us in that triangle? So they've given us that that's 350 kilometres along there, and they've given us the angle MOP, and they've also told us that's a right angle in there from the situation because of the north, south, east and west that was happening. So how did they give us angle MOP? Because they've given us that it's 225 degrees to get around to that line P. So you can work out, to make it up to 270, you can work out that little angle in there. So what's 270? Take off 225. And it's 45 degrees. So I'm going to write that in here. All right, now we're ready to find the length that's written in the blue there. I'll just call it X for the time being. Now we're ready to find that by normal right-angled trigonometry. So if we label up our triangle, we've got our hypotenuse, which has 350 written on it. We've got our opposite side, which is opposite to the angle 45. And our adjacent side's got nothing really to do with this question because there's nothing on there. So we're going to use, which is the ratio with opposite and hypotenuse? Sine. We're going to use sine 45 equals X over 350. So X equals 350 sine 45. So the answer to that is 247.487 or so. If we look at the question, it says answer correct to 2 decimal places. So that's 247. That's right, 49. 247.49, and this is in kilometres. It's asked for the distance. Right, the next question was, what was the distance from M to O? So on that same triangle, you can figure out how big the adjacent side is from M to O in the same way. But instead of going through that, did you notice that because it's a right-angled triangle and one of the angles is 45, the other angle there must be 45 as well that I'm pointing to there? And what type of triangle has got the two angles that are the same in it? It's isosceles, isn't it? So you could, if you didn't want to go back through trigonometry there, you could just go, well, that's the same length. So MO is the same as MP because it's an isosceles triangle. So it's 247.49 kilometres to 2 decimal places. Then they want to know the distance MN. And see what I'm circling here? We worked out before that that whole distance was 500 kilometres. And MP is just a part of that distance. MP is 247 or so. So how are we going to find out the rest of the distance? That's right, we need to subtract it away from 500. So 500 is the whole distance, but take off the 247.49 that we've used up, and we can see what's left. Now, This won't be totally accurate now because we've been rounding, but they did ask us to round in part 1, so we can use that rounded answer further down as we go. So it's 252.51 kilometres. All right, now we need to find the angle theta that's up in the top of that diagram. Now you could, because you know the two distances in that triangle there that we're going to peel off, you could just use normal right angle trigonometry. So I'll draw a little picture of that triangle down here. There's the angle we're trying to find, theta. We've worked out that that's 252.51. We've already worked out that that's 247.49. So we're going to do tan on this, because if we label this triangle, that's the opposite, and that's the adjacent. So tan theta equals 247.49 on 252.51. When you find theta, put that in the calculator. Remember to press shift. So 247.49 divided by 252.51. It's in the calculator. You go shift tan of that answer, and it says 44.42, etc. degrees. They want the angle to the nearest degree, so we'll just go 44 degrees. And then the last question says, what's the true bearing of n from O? So we're going around this blue that I'm making here, all the way around to there. We've got to work that out. Well, there's a few different ways that you go about doing this, but perhaps an easy way to do it would be to find out what this angle is in here and add that on to 270 degrees. And you can find that angle in there because it's the same as this one down here. It's a right angle triangle, and they told us to round it, so it's 44 degrees up the top there. So that one there must complement that 44 degrees. So 90 minus 44, you get 46 degrees in there. So that angle in there is 46. So we've got 270 plus 46. So it's 316 degrees true.